Hey, I know I said I wasn't going to give an update until I was done, but I've been busy, but I have done some more stuff to it. So, I thought I'd show you what I've been up to with it. Got my ground coming out. Let's see. I put 2 posts for positive and negative so that I can either hook up external charge source real quick or a load source. And it will be protected by this 150 amp breaker, which has a trip point of 188. And this right here is a 5 amp breaker, which is 6.5 amp trip point, which powers these 2 1/4-inch mono jacks. I plan on putting 2 more in for the Harbor Freight fluorescents. And let's see, it's a 60 amp trip point 75 for load controller, 80 amp ground fault protector interrupter, I think is what it's called, for the solar array. And then solar panels coming into the charge controller to the battery, 60 amp, 75 trip points. Let's see, capacitor bank, 80 amp breaker, 100 amp trip point, 200 main battery bank, whatever goes in or out of the battery bank through here. I think combined 2-leg 200 amp, I think it's 512 amp trip point. Let's see, fuse for the trimetric, fuse for the capacitor bank amp gauge, all the indicators for each breaker, either closed or open tripped. And then these switches here, and these are all LEDs, by the way. All of them. Okay, now, these are switches, and they have an LED ring. That's what this fuse protects, is all the LEDs, and also the LED that's in here for lighting it up. So what this is going to be, this ring's going to be on all the time so that I can see it in the dark. Excuse me, when I turn that on, that'll turn on all my indicators, including the lighting for that, and these. And then when this is turned on, this will be on all the time, this ring. So, and this is going to turn on an LEDs that are pointed towards the front of this panel. And then for the rest of these, the rings will come on when I turn it on, by whatever I turn on. This is going to be for a fluorescent nearby. And then these 2, I don't know yet. I just got a bunch of them the same so they'd look good. So whatever future I may use these for, I don't know yet. Let's see, what else have I done? Here, I'll open it up. I've done some wiring. Got my positive and my negative bus bar. 3 relays. And let's see, in here is my ground bus bar. And that's my capacitor shunt. And you're probably wondering where the trimetric shunt is. Well, I'm going to have that mounted out of the box because I want to keep it from getting hot so I don't lose the resistant value of it. Because I don't know if I'll ever draw the max of the trimetric, which would be 500. But you're not supposed to draw, I think any more than 300 amps continuous. Oh, wait a minute. I think it's 400 amps continuous. 300 amps with peaks. 300 continuous peaks, yeah. Sorry, I'm a little groggy. My allergies have been killing me lately. These relays here, I'll show you what that's for. Okay, so the indicator for the breakers, right? Well, I got Airpax breakers. And you see that external set of contacts. I got a common, normally open, normally closed. So when my breaker trips or is turned off manually, these externals will open. Open for the green light and close for the red light to say that it's open or tripped, the breaker. But there is 3 of them that I have that only open or close, because you got both contacts, when it's tripped. So what I've done is also tapped in to decide that it will be dead and send the signal out to a relay. And of course, my GFPI, I think it's called, ground fault protection interrupter, doesn't have an external contact, so I'm doing the same thing there. And let's see, wait a minute, which one is it? I think it's this one here. That's the capacitor. It only does the trip point as well for those external contacts. So they're running over to those relays, and then I'm controlling the LEDs. Let's see, I'll put in the terminal strip here for my negative and positive for all my indicator LEDs. We'll be going through that and protected by the fuse, which is over here. And this is actually a motor terminal strip that I made that I can use for terminal strip. It may eventually cut me out a piece of bar to put over these instead of this wire. And like I said, I'm going to be putting in 2 more 1/4-inch mono jacks for this Harbor Freight Solar Kit fluorescents. But other than that, I'm going to be doing 250 kc mil MCM for my battery breaker, and 6 gauge from my controllers, and I think it's going to be 2 gauge for the posts here, 188 trip point. So I'm at the point where I need to get some soldering done from my fuses and for my external contacts, and then I'll be ready to start mounting it so I can get my measurements of how long battery cable and all that stuff I'm going to need. But I figured I'd show you where I was at since it's been a while, and it's probably going to be a while yet before I get back to soldering. Having a cookout today, so I'll probably be worth a crap tomorrow. Okay, drink for the day, Tennessee honey and Coke, and that's really good. Can't wait. It's going to be a good time tonight, or should I say this evening. Got everything set up. Figured I'd update you on the solar system as of right now. I got 2 more kits out there. The 4 in the back are, they're from Harbor Freight, and so are the 2 up front. But the 4 in the back are Chicago Electric, and Harbor Freight was gone with something new. It's called Thunderbolt Solar. And I'd have to say the frames that hold the panels up are pretty nice. And you wouldn't have to take it apart if you want to take it somewhere. The legs just fold down when you take the bolt out. And also, the legs can be set at different angles for your panels. So you can at least have some play with the seasons, you know what I mean? I'm using bricks to try and increase the angle some more, because I'm trying to get it up to at least 70 would be nice, but they're at like 66, 68 right now degrees. Let's see, still 4 batteries, still the Xantrax charge controller and load controller, but let's see. Around the peak today, I was putting in 11 amps. Well, 10.75 amps. The only bad thing about these displays, they're not really that great at being accurate. They're sometimes a half an amp to a quarter amp away, and they only go one full solid amp at a time. So I could be drawing 10.75 and it'd say 11, you know. So it's the only thing I don't like about these displays. They are nice, but I just wish it was more closer to the actual amperage. Let's see, grid tie still working. Yep, maybe not. Yeah, I'm at a problem here because I need to step it up to 10 gauge. I'm at 12, and it's getting to the point where, yeah, display, it's just, there's not enough power for it, you know. But it's here, I'll turn my light on here. Oop. 300 watt grid tie inverter. But I also need step up gauge because I can't get the full amount from the panels anymore. I'm actually got more panel out there than my cable can handle, 12 gauge. And I'm pulling 12 amps, so that means I'm pulling 2 out of the bank and 10 from the solar. Show you what I'm putting in. Here, let me try taking off the light. There. 1.22 amps. Here, let me put my hand back up there. That's not working too well. Let's see, 120 watts. I'm putting in 1 kilowatt a day on a full sunny day. And that's just in one leg, of course. So I'm putting it in the leg that I usually have a higher amperage draw on. So that way, keep it balanced. But anyway, I hope I didn't bore you guys. I know I don't sound excited. It's probably because I already did this video, but it crapped out on me. So yeah. And also, here's my capacitor bank. If you're wondering what was under that. So yeah, I know I need to hurry up and get that control panel fixed, so everything will be fused and breakered, because nothing really is, except for my inverter over there. So yeah, hope you enjoy.